We're going to continue with the question, and the question now says, calculate the magnitude of the applied force. Force F is now removed, so that was the force to the left is now removed, and block P accelerates to the right. The coefficient between block P and the horizontal surface is 0,4. Right, so now looking at the setup, so we actually have block P and we have the tension in the rope, it's attached to R, and we've got the force of friction acting back on our object. So that is basically the situation. So this is block P. So now, if I have a look at our situation, we can go work out the new force of friction is not 15 newtons any longer. So now we have to use our little formula. Now, you will find this on your information sheet. So force of friction is equal to the kinetic coefficient multiplied by the normal force. They told us in the question that the coefficient is 0,4. And the normal force is obviously going to be the mass of the object. Now, object P has a mass of 3 kilograms. So it's going to be 3 times 9,8. Now we're going to go to our calculator and we're going to input that. So clear. So we're going to have 0.4 multiplied by 3 multiplied by 9.8. And that is going to give us 11,76 newtons. Always remember to round off to 2 decimal places. So it states that read the instructions very carefully on the front cover of your question paper, and it says round off to 2 decimal places, so please do that. And don't round 11,76 up to 12. So be precise, all right? So we are very accurate, so it's 11,76 newtons. Good. So now we've got the friction. Right, so looking at my free body diagram here, to work out F net. So once again, we know F net, which is Newton's second law, is equal to ma. Now, the net force is going to be T minus the friction, and it's going to equal ma. Now, the tension, we don't know yet, minus the force of friction was 11,76. We just calculated it over here. Is equal to the mass of the object is 3a. Now the tension is going to be equal to, so let me just get more space here. Okay. All right. So the tension in the string from the previous question was 78,4. Minus, sorry, I'm just losing my rhythm here, is going to be, no, let me just erase this. Oh, the eraser's not working again today. Okay, so you're just going to have to bear with me while I just ignore this. All right, so we've got T minus 11,76 is equal to 3a, and that is our first expression. Now looking at the second part of the expression or of the question, we've got Fg minus T equals ma. So this is for the 8 kg object. So the 8 kg object, all right, so if I look at the 8 kg object, it's got force of gravity acting down. It's the 8 kg, and if we have a look at the tension in the rope, which way is the system moving? It's moving down. And we always go the force of gravity greater than T. So we're going to say F net equals ma. So it's always the bigger force minus the smaller one. So it's Fg minus T equals ma. Now we're going to substitute into that. So the force of gravity is for the 8 kg object. So it's going to be 8 times 9,8 minus T equals 8a. Okay, and so now we're going to get 78,4 minus T equals 8a. And there's our second equation. So what we're going to do now, we're going to add the two together. So we've got T minus 11,76 is equal to 3a. If you wanted to, you could also make t the subject of the formula. So it doesn't really matter how you do it. There's lots of ways of doing it. But let us do that. So t is equal to 11,76 plus 3a. And we're going to sub it into this equation. So we've got 78,4 minus, so we're going to sub in this whole thing here, 11,76 plus 3a equals 8a. And now it's easy. Now we're going to solve. So 78, we're going to take the negative into the bracket, minus 11,76 minus 3a equals 8a. So to simplify it, we're going to have 78,4 minus 11,76. You can do that on your calculator and you'll get 66,64. And let us take the minus 3 across the bracket is equal to 11a. Now it's easy to solve. So now we're going to find a is equal to 66,64 divided by 11. And that will be the acceleration of the system. And we'll use our calculator. So if I can find it, oopsie, sorry. Calculator is going to be, oh dear, sorry about that. All right, so we're back again. So I just want to move the calculator. No, it's not going to let me move. So it's going to be 66.64 divided by 11. And we're going to get, there's my acceleration. So therefore, a is equal to 6,06 meters per second per second. Now the question says calculate the magnitude of the acceleration. So there's no need to put a direction in. But if they just said calculate the acceleration, you would need to put a direction. So what would be the direction? It's obviously going to move in the direction of the hanging object. So you could say it's going to move in the direction of r, or you could say it's going to move in the direction of the suspended object, or it's going to move to the right. So that would be the acceleration of the system. So just watch for these examples. So just remember that the tension in the rope is the same throughout, connected from object P to object R. The tension in the rope will be the same. And once you've got that, remember there's no normal force acting on your suspended objects. They're hanging in the air, there's no surface. A normal force is only present when there's a surface.